Hey students, Mr. Roberts here. Back with you to go over lesson 7.2b. We are still talking about equations with addition and subtraction today. So this is what we were doing yesterday, where we used railroad tracks of the equal sign. We do the opposite of the adding 15, which is subtract 15, and then that leaves the x by itself. And then 24 minus 15, we get the answer, x equals that. And then same thing with subtraction. So we have the m we want to get by itself. So this one's not really the best setup, and you're going to see better setups of questions as we go along today. Let's get started with our bell work. Okay, so let's take a look at this bell work here. We're looking at number 1, which expression is equal to 8 plus 2b times c. Now, looking at the expression that is in the parentheses, the 8 plus 2b, if you guys remember back, we talked about doing this. Oh, wrong color. We talked about doing this. We have 8 plus 2b. And what number can be taken out of that? Well, we can take the 2 out. This turns into a 4. This turns into a b. So we have the 2 on the outside with 4 plus b on the inside. So we can see right here that this part that we just came up with is right here. Now that times c out there is just going to stay there because you can't do anything with it. Remember, expressions, we're not looking for an answer. We're just looking to expand it. We're looking for something that if we did that, like the distributive property here, 8 2b times c. So that right here turns back into this. So that a is the answer. Let's take a look at number 2. Use an integer to describe the situation. 78 degrees above 0. We would just go 78 degrees. On the second one, now in Go Formative, I don't know if it'll be 78 or 78 degrees. So try 78, and if it's marked wrong, do 78 degrees. On this next one, we are going to have 200 degrees below 0. That would be negative 200 degrees. Again, it might be negative 200, it might be negative 200 degrees. You may have to put it in both ways, see which one's right. This one wants us to write an expression to represent 9 fewer than 8 times a number. So this can be a little bit tricky because the words, you have to think about the words for a minute. It says 9 fewer than 8. Well, is that 9 minus 8? Is that really showing 9 fewer than 8? Or is it 8 minus 9? Because remember, there's a than here, right? So if there's a than, that means they flip places. So this is 8 minus 9 times a number. Well, I like to use x, so I'm just going to put 9x. So there is that. Your bell work is done. Let's move on to the next page. All right, so we have this in your notes, and I believe it's page 56. It's right around there. It's 56 or 57. And we need to talk about writing equations and expressions. Now, I'm going to start with the expressions because we have already talked about these expressions. An expression is just a number. It's not a number sentence. Let's look at some examples really quick. 2x, x plus 4, 2 plus 2. All of these are expressions. They are missing an equal sign. So some non-examples would be this. X plus 4 equals 6. 2x equals 4. 2 plus 2 equals 4. So you can see that an expression, the definition of it would be that it is a number sentence without an equal sign, really. So I'm going to write that down. Number sentence with no equal sign. Okay? Algebraic example, well, we already used some algebraic examples there because we used x plus 4, well, over here, x plus 4. So I'm going to write that one down again. There's too many to explain here. Or, you know, here's one with division. You could go x over 6. So all of those are different algebraic examples of expressions. Now that we've kind of reviewed expressions, and we've already talked about equations a little bit, what is an equation? It is a number sentence. And a number sentence, now, if you want to look, I know we're not in language arts, but think about language arts for just a minute. What is a sentence? Well, a sentence is a complete thought, right? Can we have sentences that are incomplete sentences? Absolutely. And those are like expressions. So a number sentence is complete. It completes something. And an equation completes something. It has an equal sign. It shows us where we're trying to get to. So some algebraic examples of an equation are like 2x equals 4. X plus 4 equals 8. Let's see. X plus x equals 4. So these are algebraic examples. And then some examples of an equation, some regular old, like 4 plus 2 equals 6. Or 4 divided by 2 equals 2. Or 2 times 3 equals 6. Those are some examples. And some non-examples, well, we're going to write some expressions here. We're going to go 4 plus 2. 4 divided by 2. 2 times 3. So equations have equal signs. That's what makes them equations. Expressions are just incomplete number sentences. They don't have an equal sign. It doesn't tell us where we're trying to get to. So there are your notes for today. And hopefully as we are going along, that you can kind of be thinking back to your notes of how your assignment applies. So let's look at your practice. Okay, so we're going to be looking at some of these questions, and the questions are kind of, we have to see if the given value is a solution. So if x equals 12, what we're saying is that this little 12 right here can be plugged in and substituted for x. So we're going to go 34 plus 12. We get 46. So is this a solution? Yes, this is a solution to that equation. So let's take a look at number 2 now. All right. So if I take this 22 and plug it in for y, we have 22 minus 9. Well, what is 22 minus 9? We get 13. Does it match this? It doesn't. So this is not a solution. So it is no. Let's take a look at number 3 now. Number 3 is we're kind of throwing this idea of multiplication in here. We don't actually start talking about it till the next day, tomorrow, but we're going to throw that idea out to you right now. I'm going to take this 9 and plug it in for D. So this really is saying 6 times 9. Does it equal 54? Yes, it does. So this is a yes. Let's take a look at number 4 now. Number 4, we are going to take that 39 and we are going to plug him in for the n, just like because n equals it. So we have 39 divided by 3. And here's a little shortcut. Yes, you can use your calculator. Well, how many times does 3 go into 9? 3. How many times does 3 go into 3? 1. So we get 13. So 13, it matches up. So this one is also a yes. So really just substitution there. We're just substituting a number in to see if it works. Now it wants us to solve the equations. We're kind of going back to what we did yesterday. So we're going to draw our railroad track. We're going to subtract 7 here, subtract 7 here. We get k equals 4. Put a box around it. So there is that one. Try number 6 on your own. pause now. Did you get P equals 37? If you did it correct. You can plug 37 in for P there. 37 minus 24 is 13. So that is the correct answer. Let's look at number 7 now. Well, actually, you know what? I want you to try number 7 on your own. So pause now. Did you get B equals 23? If you did it correctly. 23 minus 16 equals 7. All right, the reason I wanted to do this one is because, it has fractions. A lot of people see these and they get a little bit scared. So I just wanted to show you that it's not anything that is scary. It's something that you have actually done before. So a fraction is a number. We treat it just like a whole number. So we have 2/5. So I'm going to subtract 2/5. This is gone. We're left with M. I have to subtract 2/5 from 5/6. Now, we have to kind of go back in the past. I know it's been a while since you've done fractions. So we're going to go 5/6 minus 2/5. And remember, we have to find a common denominator when we subtract or add fractions. So we have to find a common denominator. It so happens to be 30. I'm going to go, how did 6 turn into 30? It times by 5. Do it to the top. We get 25. How did 5 turn into 30 on the bottom? Well, we times it by 6. What we do on the bottom, we got to do on the top. 6 times 2 is 12. Now I can subtract. 25 minus 12 is 13, and then the denominator is the same. So we just bring it down. 13/30ths. And that would be M equals 13/30ths. So I know that one's a little bit more involved, and whenever we're dealing with fractions, it is a little bit more difficult, but I wanted to show you. Okay, so looking at this story problem, I actually want to do this one with you in class. So we're going to do this one together, so I'm going to skip that for right now. So let's look at your assignment now. All right, so I'm looking at your assignment here. Again, numbers 1, 2, 3, and 4, we're just using substitution. We're putting the number in for the variable. We're seeing if it works out. On 5 through 13, we are just solving the equation. Again, there's a couple of them at the bottom that have fractions, so refer back to that practice if you need to see kind of a refresher on how to do that, or come and talk to your teacher and we'll help you out as always. And then down here, we're still taking those number sentences, those word sentences, and writing them as equations. So we still want you to work on that skill because we feel like that one is a really kind of a weakness of a lot of students. So that's what we want you to do on that one. All right, guys. So, yep, I think you guys can handle most of these. We'll probably do some of these in class to kind of help you along. But give it your best shot. And don't forget to enter your answers into GoFormative. Also, don't forget to do your practice and do your notes and your bell work. All right, guys, good luck.